Hello, ladies and gentlemen. So this is my next video in the series. I'm talking about quadratics. So today we're going to talk about two different concepts, relatively easy concepts, and I felt like we could do this remotely. So hopefully you guys will remember this from Algebra 1. Like I said, the rest of the stuff we'll hopefully do face-to-face. But at any rate, so the first concept we want to talk about is maximum and minimum. Now, from your notes yesterday, you should have defined that the maximum is the highest point of the vertex and the minimum is the lowest point. So we'll say highest and lowest. Now, the highest point in terms of it's going to look like a hill. As I told you in the video yesterday, in the previous video on vocabulary, the maximum will look like a hill or a mountain, and at the top of the mountain will be our maximum. If you're dealing with a graph that looks like a valley or a U, it's going to be the lowest point. All right? So for instance, on this one, the first one, we'll call this example 1. All right? You notice that it looks like a U, so that means we're going to be looking for a minimum. Now the minimum will be the lowest point, and when you have paper, you can always draw a dot at the minimum or lowest point, in this case right here. So that way we can now trace it. Now we're going to go ahead and say it's a minimum, but we need to know the coordinates for that minimum. So remember, coordinates always take the form of x comma y. We always do our x value first and our y value second. So starting at the origin, which is over here, which is right here, we're going to count 2 spaces over here, so that's going to be our x. And then we're going to count 1 space up, which is going to be our y. All right? So since we went 2 spaces to the right, that's going to be positive 2, and 1 space up is going to be positive 1. All right? So it's pretty much easy. You guys have done this, like I said, in Algebra 1 and previous math classes, so finding coordinates isn't complicated. All right? So that's if it's a minimum. Now let's look at example number 2. This time it looks like a hill or a mountain. So we're going to draw a dot at the highest point, which is going to be our maximum. So let's go ahead and classify this as a maximum. All right. And just like we did before, we're going to start with our origin or our 0, 0 point. And we're going to do our x's, even though it's facing down, we're still going to count from the 0, 0 point. So I have 1, 2, 3, 4. So that means since I went to the left 4 this time, it's going to be a negative 4. Okay? And then 1, 2, since I went down 2 spaces, it's going to be negative 2. All right? So our maximum is negative 4, negative 2. All right? So again, that takes the form of x, y. And that's essentially going back over max and min. So the main thing is, example problems you'll have to work in a few minutes. You just need to identify whether or not what's the point and tell me whether or not it's a maximum or minimum. So I did make it multiple choice. So you will just be able to look at it and just say, is this a maximum or a minimum? And then go from there. All right. So the next concept we're going to talk about is end behaviors. So as you are noticing, I am going to pull up another picture that I drew. I could use that same one, but I decided I'm going to just do something different so you can see something else. You can actually see me go through the process of how I do my videos. So I have to import the picture and then I can write on it in my app. All right, so here we're going to talk about end behaviors. And again, from your vocabulary, you should know the end behaviors refer to how the ends of the graph are behaving. Are they both going up? Are they both going down? Now for quadratics, you should remember this from Algebra 1, your end behaviors will always be the same for both sides of the graph. When we get into polynomial graphs, which is the unit after this one, there's going to be some changes in that. But for our purposes for this unit 3, or test 3, we're going to only have the graph is only going to be pointing either up, or both down. All right. So we look at example number 3. All right. Example number 3. Now look at the graph. It's a mountain, so we know we're looking for a maximum. If we're looking for max and min, but again, now we're talking about end behaviors. So when you're doing end behaviors, you're going to follow this notation of, sorry, I don't know where I got the comma from yet. You're going to follow this notation of as x goes to negative infinity, f of x goes to another direction, and as x goes to positive infinity, f of x goes in a direction. Now, negative infinity refers to the left side of the graph, and positive infinity refers to the right side of the graph. So again, I will on the quiz, which will be after we cover one more little short section. Basically, I will put this on there, but just know on the test, it will not be left and right like this. You have to remember that left is negative, right is positive. All right, so let's look at this graph. If I look at the left side of the graph, it's pointing down. So since that's pointing down, that means that as we go down, that we're talking about all the negative y's or negative infinity. All right. And the right side, remember I told you that if the left side is going down, the right side also is going down. So we can go and put that here, but we can confirm it by looking at the right side of the graph. Okay. So this was left and this was right. Okay. So that's what you want to key in on. You want to look at the left side and the right side of the graph. Sometimes it helps to draw a line down the middle of the graph. That way you can see your left and right sections. You don't have to, but again, if that helps you to be able to see the left side of the graph and the right side of the graph, I'm all for it. All right. So then we got example number 4. All right. So again, we're going to write our notation, which is as x goes to negative infinity, f of x goes to a point, and as x goes to positive infinity, f of x will be in a direction. So again, that's left, and this is right. Now, one thing I did not mention is f of x is the same thing as y. So anytime you see f of x, you're always talking about y. So we're talking about what's happening on the y-axis. All right? So let's look at the graph. It looks like a U this time, so it's not. So we know we would have a minimum if we were looking for a minimum. But I look at the left, so I'm going to go ahead and draw my imaginary line down the middle. Again, you don't have to, but again, that might help some people keep it straight. So I look at the left side. The left side of the line is this side. This is the left. So I see that it's pointing up. If your arrow is pointing up or the graph is pointing up, then we know it's going to be positive infinity or all the positive y's. All right, then we come over to the right side and do the same thing. So it's going to be positive infinity again, because again, if the left is going up, the right has to go up. If the left is going down, the right has to go down. So that's why I say it's a fairly easy concept. Most people usually get it. It's just a simple matter of just looking at the graph and being able to tell your left from your right. If you have a problem with that, always write it out. Ms. Lambert and I won't care if you write it out. Okay? So again, that's fine. All right, so that finishes this lesson. So the next lesson will be hopefully face-to-face. And we will be talking about domain and range. So have a good day, and I will talk to you in the next one.